So, in last lecture, I had discussed about the probability distribution, and in that, you had seen about the Poisson distribution, normal distribution, and binomial distribution. Now, we are at a stage where, after completion of descriptive statistics, now we are moving towards the experimental statistics. So, this connecting link between the experimental analysis and descriptive statistics is two population parameters, we may say, and those two parameters are correlation and regression. So here today I will be discussing about the correlation. So what correlation indicates? So these correlation and regression are actually the measure of relationship between the two variables or more than two variables. So there are many different types of correlations and regressions, but for undergraduate students we have to know the basic concept of correlation and regression, basic different types of correlation, and how we will use this correlation and regression in our experimental analysis. So first of all, we will see what is bivariate population. What is bivariate population? Because this correlation is actually correlation. Just a minute. Why bivariate population? Because this correlation and regression, you need at least two variables. That is why you need a population which is being described by two variables. So a population in which each individual is measured for two different variables is known as bivariate population. So examples are height and weight, age and weight, milk yield and fat content. And here you can see graphically these are the two variables. One variable is presented on x-axis and another on the y-axis. And we will find the relationship between these two variables with the help of correlation. Now another important term is cause and effect variable. So for better understanding of correlation or regression, we must understand the concept of cause and effect variable. So out of two variables, one variable depends on another. So whatever two variables we are dealing with, one variable will be depending on the other variables. Under such condition, the independent variable is called as cause variable. So the independent variable is called as cause variable. Here you can say this is one experiment where it was tried to find out whether caffeine intake will increase the number of words recorded. So this caffeine intake is cause variable because it will cause change in the number of words recalled. So this caffeine is known as cause variable. It is an independent variable, and the number of words recalled is effect, and it is called as dependent variable. So the independent variable is called as cause, or it is also known as subject variable. So many of the textbook you will find this term subject variable, and it is generally denoted by x, while dependent variable is referred to as effect variable, and it is denoted by y. So these are the three terms associated with the variables. First one is independent and dependent variable, second one is cause and effect variable, and third one is subject and relative variable. So the subject variable is independent variable, whereas relative variable is dependent variable, and it is denoted by y. This is just by convention. You may denote in either way also, but by convention we are denoting independent variable by x and dependent variable by y. Then correlation and regression analysis is always done for continuous variable. So we have already discussed about the continuous variable. So you have to remember this correlation and regression, it is for the continuous variable. It is not applicable in case of in case where variables are discrete. Now, what are the measures of relationship? Suppose you are having two data series or two variable. You have one data series and you are having two. You have one data and in that you have two series, series 1 and series 2. Now, we are interested to know how these two series is behaving with each other. How these two series is behaving with each other. Suppose you are having color, you are having 100 pen. You are having 100 pen and in that pen you are having two data series. One is on the color of pen and another is on the price of pen. Now you want to know whether there is any relationship or how price is behaving with respect to color. How price is behaving with respect to color. Whether there is any relationship between price and color. Whether there is any trend that this particular color is having any relationship with the price. So, but I have here taken this color of the pen is a discrete variable. So, this is wrong. We have to take the continuous variable. So, now suppose milk yield and fat content. You want to know if milk yield is increasing, what will happen to the fat yield or fat content. So, how these two move together? So, for that you have to apply certain statistical measure, and the first and foremost statistical measure is correlation. First and foremost statistical measure for measuring the relationship between two variables is correlation. So, a relationship exists when changes in one variable tend to be accompanied by consistent and predictable change in the other variable. So, this consistent and predictable change that we have to identify with the help of correlation. Now, nature of the correlation. So, what are the nature of correlation? This correlation is often used as a means of prediction. So, suppose you want to predict that for a particular milk yield of a cow, you want to predict how much fat content will be there or how much fat percentage that cow will be yielding. So, for that, the first and foremost step is that you have to know about the correlation between the fat yield and milk yield. Now, correlation tells us how related two variables are. We have already seen. Then correlation does not imply causation. So, that is why I have told you earlier the cause and effect variable. So, this correlation in regression you will know that it is a relationship based on cause and effect. But this correlation it does not imply causation. Means one variable is not a cause of another variable or vice versa. Then correlations are measured both in descriptive as well as experimental research. So, I have already told you this is the connecting link between the descriptive statistics and experimental statistics. So, for example, you can see the correlation between the marks of statistics and epidemiology of BBSc and AH student. So, if you want to describe the BBSc and AH students with respect to marks in statistics and epidemiology, then you can use the correlation. Whereas, in experiment also you can use, if you want to know the relationship between the heart girth and body weight in Mehsana goat, then this is also you need to know about the correlation. So, this correlation is well used both in descriptive statistics as well as experimental statistics. Now, coming to the correlation, we want to know the difference between the correlation and correlation coefficient or coefficient of correlation. So, what correlation states? It is the relationship between the two variables. It states the relationship between the two variables. Example, between height and weight. What is the relationship between height and weight? Or what is the relationship between feed consumption and weight gain? And similarly, what is the relationship between milk yield and fat content? Whereas coefficient of correlation, it measures the strength. It measures the strength of linear relationship between the two variables. So, with the help of coefficient of correlation, we may say that how much these two variables are related. What is the strength of relation? Suppose you want to tell that if fat yield is increasing, or suppose milk yield is increasing, fat content will decrease. Suppose this is your assumption. But how much milk is, suppose 1 unit, if there is 1 minute increase in milk yield, how much fat content will be decreased. So that thing will be determined with the help of coefficient of correlation. So it tells us how strongly two variables are related. That means the coefficient of correlation measures the strength of linear relationship between the two variables. The correlation coefficient is also called as simple correlation coefficient, or product moment correlation coefficient, or Karl Pearson coefficient of correlation. So these three terms you should remember: simple correlation coefficient, product moment correlation coefficient, or Karl Pearson coefficient of correlation, because it was discovered by Karl Pearson, the famous statistician. Then if you want to know the correlation of a sample, the sample correlation, it may be indicated by small letter r. So instead of sample correlation, if somebody is writing small r, then you have to understand that he is talking about the correlation of sample, correlation coefficient of sample. Whereas the correlation coefficient of population is indicated by rho. So instead of population correlation coefficient, you may denote it by rho. Now statistically, correlation coefficient can be defined as ratio of covariance. This is the statistical definition of correlation coefficient, or with the help of this definition, the formula of correlation coefficient is derived. So what is it? It is the ratio of covariance. Ratio of covariance. Co means together, or variance means variance we have already studied. It is the ratio of covariance to the geometric mean of the variances. So we know about the geometric mean. So it is the ratio of what? Ratio of what? It is the ratio of covariance of two variables and geometric mean of the two variables. So if you will see the formula, then it will be more clearer to you. Now, okay, we will see the formula in the later slides. So now the coefficient of correlation measures we have already studied that it measures the degree, that is strength and direction of the linear relationship between two random variables. It is a measure of interdependence, how these two variables are dependent from each other, or how these two variables are interdependent with each other. It is measured by correlation coefficient. It measures how two variables co-vary, means how two variables vary together. The two variables are said to be correlated if with the change in the value of one variable, there is change in the value of another variable. So this is about the correlation coefficient. It states that if there is change in value of one variable, how much change will be there in another variable. Now, what are the methods of determination of correlation coefficient? So there are few methods I will be discussing here about the methods determination of correlation coefficient. So first method is from scatter diagram. So scatter diagram, what is scatter diagram? The scatter diagram is also known as scatter plot. The scatter plot allow us to visualize the relationship between two variables. So if you want to, you are having data on milk yield and data on fat percentage. So this by simply observing data, you cannot say with confidence that what is the correlation between these two variables. So for that, you have to prepare the scatter diagram. So what is scatter diagram? It is a graphical presentation of bivariate population. It is a graphical presentation. Here you can see this is the graphical presentation. Suppose this is milk yield and this is fat percentage. So for each of the pair of values, pair of values means variable 1 and variable 2 of the variable, a dot is plotted on the graph. You have to plot or you have to put a dot on the graph for each pair of variables. So suppose milk yield is 3 kg, suppose milk yield is 3 kg and fat percentage is 2.5. So this is the dot. This is the dot we can put on the graph paper. These dots give an indication of the direction of the correlation. Here you can see that some quantity x variable, for if x variable is 3, the corresponding y is 7. So we have put a dot here. Then another value for x9. For x9, the y is 20. So with similarly we can put the dots here and there, and now you can join. So this will give the idea of direction of correlation. It will give only the idea of direction of correlation, but it will not give the idea of quantity, how much strength. So this will only indicate the correlation, but it will not indicate about the correlation coefficient. So if the slope or ellipse, if the slope appears to be upward, here you can see the slope appears to be upward from the left bottom to the right top. So this is the left bottom, from left bottom to right top it is upward. This indicates the sign of positive correlation. So this is the sign of positive correlation. Similarly, if the slope appears to be downward from the top to the right bottom, left top to the right bottom, then this indicates the negative correlation. This indicates the negative correlation. And if there is no any direction, here you can see there is no any direction, either upward nor downward, then it indicates the absence of correlation, and that is why it is called as no correlation. No correlation, or sometimes it is also called as there is zero correlation, zero correlation or no correlation. Here you can see if the diagram appears in straight line, it indicates the signs of perfect correlation. If there is straight line, in the previous slides we had seen that there is band. So if such kind of those kind of graph you are getting, that means it is imperfect correlation. But if you are getting a straight line, then it indicates the perfect correlation. Here you can see that left bottom to right top it is upward trend, so it is a perfect correlation. So you will indicate it by +1. Conversely, you can see that from left top to right bottom it is decreasing, then it is called as perfect negative correlation. It indicates by -1. But I have told you earlier, this scatter diagram will not provide the exact degree of correlation. It will not provide the exact degree of correlation. That means you will not get any numerical value. So that means the strength of association, strength of correlation between the two variables, you will not be able to determine with the help of scattered diagram. So for that you have to look upon the formula. So this is the formula. So now the second method of determination of correlation is from the formula of correlation. So formula was given by Karl Pearson. So it is also known as Pearson product moment correlation coefficient. This is the most common measures of correlation. So here I have already described it, that correlation between x and y. Suppose x and y are two variables. The correlation between x and y will be represented by covariance between the two variables, that is covariance x and y, and the geometric mean of variance of these two variables, geometric mean of variance of x and variance of y. So this is the broad formula of correlation coefficient. Rxy is equal to covariance xy divided by under root variance x into variance y. That means geometric mean of variance x and variance y. And I have told you this R represents the sample correlation of a sample which has been taken from the population. This can also be represented, under root variance is also called as standard deviation. So covariance xy divided by standard deviation of x into standard deviation of y. If you expand the formula, because you know the formula of variance, and in case of covariance, you know the formula of variance, it is summation x square minus summation variance, you are well aware, summation x square minus summation x ni whole square divided by n minus 1. So what we will do, we will expand this formula. What we will do, we will expand this formula. How we will expand this formula? Instead of variance, you will write covariance. So covariance, instead of summation x square, here it is summation xy minus summation x into summation y. What we used to write, summation x whole means under bracket square. So instead of that, you have to write summation x into summation y divided by n. So this is the covariance of x and y, and under root you have to write the variance of x and the variance of y. So this is just an extension of covariance xy divided by under root variance x and variance y. Now this is the another solution of that problem. So this is the basic formula. This is the formula that you should remember, and if you know this formula, easily you can write this formula. This is the working formula, and this is the formula that you should know, because it will be very easy to remember this formula, and if you remember this formula, you will be easily writing this formula. Now what it is telling, the test of significance. So what you have till now, you have find out the correlation coefficient of the sample. Now you have to see whether this correlation coefficient that you have obtained from the formula, it is different from the correlation coefficient of the population, or it is one and same. So what I will explain it here. If each individual from a bivariate population is sampled, then the sample correlation coefficient, I have already told, sample correlation coefficient R would be same as the population correlation coefficient, that is rho. So our whenever we are testing the significance, you have to assume, you have to hypothesize. What you have to hypothesize? You will study test of hypothesis in the another lecture. But what you have to hypothesize, that the sample correlation or the population sample correlation coefficient and population correlation coefficient are one and the same. But the problem is that what you are doing, whenever you are estimating correlation coefficient, you are estimating correlation coefficient on sample, and based on sample you are telling that whatever you are measuring on the sample, it is applicable to population also. So what you are doing, this is the population. Suppose this is the population, and from that population you are taking a small sample. Now here you are finding R, that is correlation between the two variables. Here in population already there was rho, and now you are telling R is equal to rho. So whether this is true, how you will determine, because you are estimating on sample and you are generalizing it in the population. So testing sample and commenting on population whether it is correct or not. So for that you have to test the significance. Now you will see. So what we are doing is the difference. Suppose कि there is difference, R is not equal to rho. R is not equal to rho. That means sample correlation coefficient is not equal to the population correlation coefficient. So is the difference obtained is true or it is by chance? So that also you have to determine whether this difference is significant, it is true difference, or just Simply it is by chance because you have taken a wrong sample. Suppose you have taken a wrong sample. Suppose there is a heap of potatoes. And there was only 2 potatoes that were rotten. Only 2 potatoes were rotten in the population. And you draw a sample of 2 potato, and by chance you got those 2 rotten potato. So now you will tell that okay, all the potatoes in that heap of potato is rotten. But this is wrong. Why this is wrong? Because this conclusion you have arrived because only due to chance. Because by chance only you picked those 2 potatoes which were rotten. So here you have to rule out that thing also, whether the difference between the correlation coefficient of sample and correlation coefficient of population is true difference or it is by chance. So for that you have to utilize the t-test. So t-test we will be studying in further later classes also, but here you have to test the significance of correlation coefficient with t-test. Okay, so how we will see how we will test the correlation coefficient, and then when in test of significance, when we will study t-test, then it will be more clearer to you. So this is the test of significance. Here the null hypothesis. So whenever we are testing the significance, you have to hypothesize. The first one is null hypothesis. Null hypothesis means there is no difference. That means rho and rho and r is equal, and that is 0. Rho and r is equal, that is 0. It assumes that coefficient of correlation in the population is not different from the 0. The alternative hypothesis is that no, rho is not equal to 0. Rho is not equal to 0. Now you just see the normal distribution curve. I have already told you in the last lecture about the normal distribution curve. So this is the normal distribution curve, and I have told you this is the 95% of the observation is falling. 95% of the observation is falling between plus minus 2 standard deviation. So now suppose our observation, whatever thing that I have calculated with the formula, if it is falling between these two regions, that means in the 95% of the region we will accept this. That means what we will accept that there is no correlation between the sample. There is no correlation between the two variables, or the correlation between the two variables in the sample is 0 as of the population. Whereas if it is falling beyond 95% of the observation, that means in these two area. So if it is falling in these two area, this is called as a rejection region. We will reject the null hypothesis. That means we will accept the alternate hypothesis. What was the alternate hypothesis? Okay, this correlation between these two variables is not by chance, but there was something. That is why there is a difference between the correlation. So this is how we are testing the significance of correlation coefficient, whether it is falling in the acceptance region or it is falling in the rejection region. Now by applying t-test, we confirm whether the sample in which the coefficient of correlation has been obtained belongs to population with sigma is equal to rho is equal to 0. So whether these two, if it is falling in 95% of the area, that means it is from the population which is having correlation of 0. In different set of condition, here I have used only t-test, but in different set of conditions we may use z-test or chi-square test. This z-test and chi-square test you will study in the in future, but here you have to know about only t-test. This is not in your syllabus, so we will be concentrating on the t-test of significance of correlation coefficient. Now this is the way how we are testing the significance. So in this hypothesis testing of correlation coefficient, the test statistic is T is equal to R minus rho. R minus rho means sample correlation minus population correlation. So you are already having population correlation with you, and you are having sample correlation that you have calculated from the formula. It is divided by standard error of the correlation coefficient that you have estimated. So what is the formula for a standard error of correlation coefficient? So standard error of correlation coefficient is under root 1 minus r square divided by n minus 2. What is n minus 2? N minus 2 is the degree of freedom. So previously I have told you that degree of freedom is generally it is n minus 1. Why n minus 1? Because out of total variables you want to determine the value of variable which you can determine at your will. So suppose there are 10 values, so 9 you can determine at your will, but at last one will be chosen in such a way that overall sum will be 0. So last one will not be determined at your will. But why in correlation coefficient? In correlation, the degree of freedom is coming n minus 2 because there are two variables, the variable x and variable y. So in x variable you will have n minus 1 independence, and in y variable it is n minus 2. So n minus 1. So combinedly the correlation coefficient will be coming to n minus 2. So you have to remember the degree of freedom in determining the correlation coefficient, it is n minus 2. So this is the formula for standard error. Now after getting the value of t, you have to compare the calculated value of the t with the tabulated value at n minus 2 degree of freedom. We have already seen how it is n minus 2 is coming. At desired, that is 5% level of significance. 5% level of significance means, if you remember this graph, this is because 95% is the acceptance region. 95% is the acceptance region, and 5%, 2.5% this side and 2.5% this side. So this will be the rejection region. So you have to determine whether you have to test the significance at 95% level or 99% level. How it will be 99%? So plus minus 3 standard deviation, it will be 99%. So this 99%, this is the more stringent. So this 99% will be the acceptance region, and 1% will be the rejection region. That means 0.5% this side and 0.5% this side. So 1% will be the rejection region. So you have to determine whether you have to see the test of significance at 5% level or 1% level. 5% level means 95% of the area will be coming under acceptance region, and only 5% will be the rejection region. Whereas if you are seeing at 1% level of significance, that means 99% of the area will be acceptance region and 1% will be the rejection region. So this 1% will be the more stringent. Well, there is only means by chance only 1% chance is there that this correlation coefficient is coming by chance, not because of any effect or relationship between the two variables. So now the value of correlation coefficient denotes the strength of association, we have already seen, and it is illustrated by the following diagram. So this is the diagram. Here you can say this is the negative correlation coefficient and this is the positive correlation coefficient. If correlation coefficient is 0, suppose if correlation coefficient is 0, then that means there is no correlation. If correlation coefficient is less than 0.25 but greater than 0, less than 0.25 but greater than 0, then it is weak correlation. So sometimes in your examination these kind of questions are coming in the objective portion. If it is more than 0 but less than 0.25, it is weak correlation. If it is more than 0.25 but less than 0.75. More than 0.25, that means this region. So this is known as intermediate correlation. And if it is more than 0.75, then it is strong correlation, and this will be applicable on both sides, negative side and positive side also. So, and if it is -1, then it is your perfect negative correlation. If it is +1, it is called as perfect positive correlation. So this you may see some of the question in your objective examination. Now, what are the properties of correlation coefficient? So correlation coefficient ranges from -1 to +1. So this is very important. Many times you will see this type of question in competitive examination and your annual board examination also. It is not affected either by change of origin or change of scale. So this change of origin and change of scale we have discussed in detail when we were studying about the variance. So there you can go and refer what is change of origin and change of scale. So it is not getting affected either by change of origin and change of scale. So this is also a very important point. You will be asked in examination. You will be asked in your examination, this either internal examination or in board examination, to write about the property of correlation coefficient. So these are the properties of correlation coefficient. These are the properties. I have missed to write the properties. These are the properties of correlation coefficient. It is also not affected by interchange of x and y. So for correlation coefficient, either you find the correlation between x and y or y and x, both are one and same. So both will be different in case of regression coefficient. That is why this is a very important point. You have to remember the correlation between x and y will be equal to correlation between y and x. Then another point is, it is a geometric mean of two regression coefficient. So this I have written here in advance because you don't know now at this stage about the regression coefficient. But just you remember that it is the correlation is equal to geometric mean of two regression coefficient. Geometric mean of two regression coefficient. So whenever you are having geometric mean of two regression coefficient matlab bx means bxy into byx. The correlation between the two variable, regression coefficient between two variable x and y and x. So this will be equal to correlation coefficient. We will see in the regression when we will be studying about the regression. Now, it is not based on the cause and effect relationship. So we have already discussed this is not based on the cause and effect relationship. It is independent of unit of measurement. This is also very important point, because this correlation coefficient does not have any unit. You will see the regression coefficient is having unit, whereas this correlation coefficient is having no unit. The correlation is defined only if both the standard deviation are finite and both of them are non-zero. So if standard deviations are finite and they are non-zero, that means more than 0 and it should not reach up to infinity. So this, under this condition, this correlation can be defined, because you know the correlation coefficient R is equal to covariance xy divided by standard deviation x into standard deviation y. So if standard deviation is 0, then this term will be infinity, and if it will be infinite, the correlation coefficient will be 0. So you cannot define correlation coefficient if the standard deviation are non-finite and 0. Similarly, if variables are independent, then the correlation is 0. Suppose there is two independent variables, then x and y, they don't have any relationship. In such case, correlation coefficient will be 0, but opposite is not true. Opposite is not true. You just take any example and you try to find out or trying to validate this point, how this opposite is not true. Now, another method of determination of correlation coefficient is the Spearman's rank correlation. Spearman's rank correlation, it is given by Spearman. It is given by Spearman. This is the photograph of Spearman. The Pearson correlation, you know about the Pearson correlation, at least one of the two variables follow a normal distribution. The problem with the Pearson correlation was that it should either one of the variables should follow normal distribution, and the relationship between the two variables should be linear. These are the two prerequisites for finding correlation coefficient, Pearson correlation coefficient. Whereas Spearman rank correlation is the non-parametric measures of correlation. It is non-parametric. So we have to discuss one topic about the parametric and non-parametric measures. So in that we will see this in detail, what is non-parametric measures of correlation, what is non-parametric test. But here you have to remember that Spearman's rank correlation is non-parametric test, whereas correlation, that means Pearson correlation was the parametric test. So this correlation applies in a data if data is in the form of rank. Suppose there is you are having rank based on OGPA. In your class you are having rank of students based on OGPA, and then second one there is rank of running of the rank of students how they run. So based on running there is one rank, and based on OGPA there is one rank. Now you want to find out the association between these two, whether the student who is good in running, whether he is good in study also. So with this, if you want to find out the relationship between these two ranks, then you have to apply the rank correlation. So what is the formula for rank correlation? It is RS, because it is Spearman's rank correlation. It is 1 minus 6 sigma d square. D is the difference between the two ranks. Suppose student 1 is Ram. So Ram is having 5th rank in studying, whereas 4th rank in running. So the difference between these two ranks, 5 minus 4, that is 1. And the rank square, why has been squared? Because the difference, suppose difference is coming to minus. If you will square it, then minus will become plus. So 6 sigma d square divided by n into n square minus 1. So this is the formula for rank correlation. So this is how we are finding the correlation between the variables. So you have seen about the basic concept of correlation, what is the difference between correlation and correlation coefficient, what are the different methods of estimation of correlation coefficient, and what are the properties of correlation coefficient, and lastly you have seen about the Spearman's rank correlation coefficient, how it is different from the Pearson rank correlation coefficient. So in next class we will be studying about the regression. Thank you.